Welcome to myprojectbazaar.com. Our product title is Optimal Allocation of Combined DG and Capacitor Units for Voltage Stability. And let us see about the abstract of our product. In this proposed implementation is based on heuristic computation algorithm for optimal placement for distributed generation and shunt capacitors. Development of various technology of distributed generation and their cost effectiveness have increased the use of these resources. Shunt capacitor as reactive power compensator are also the equipment that inject reactive power to distribution network in order to improve voltage profile, release a part of the network capacity and also reduce the losses. The objective function was defined based on the reduction of active power losses. The performance of the proposed method tested on 239 bus and 69 bus IEEE standard system. In spite of the objective function defined based on active losses reduction, and this result is compared with cuckoo search algorithm for both 39 and 69 bus IEEE standard system. This proposed work is implemented in MATLAB simulating environment. Finally, we conclude which one of the algorithm is best for the result, both the distributed generation allocations in the power system. Next we see about the flow diagram of our process. In this proposed implementation is done in the two kind of flows. One is the IC algorithm based, another one cuckoo search algorithm based. In both algorithm, first initialize that data is getting from the IEEE standard bus system. So in that bus system that having bus data and then branch data and then the generation cost data. So those data having a lot of parameters values for example real power and reactive power and demand of the load, real and reactive, and reactance, resistance, and so on. The values are given in the values. Then the voltage angle, the voltage between two branches, and the maximum value of the reactive power and minimum value of the reactive power and real and reactive maximum. So that values are given in the IEEE standard bus system. So first of all, and in that value is getting from the data in the mat file format. After that, calling into the main coding, then we function the objective function derived using of the formulas. So if you want to calculate the branch data, for example bus 1 to 2, then we change in voltage V1 minus V2 we find out, that is the Vi, and also Vj means V2 minus V1. So those are the branches value calculated method. Then that values are calculated. After that we assign the equality constraints. So equality constraint we directly formulated, and also using of that formulation we calculated that. Then that calculated value is must between the inequality constraint. The inequality constraint is minimum and maximum values. In between that the equality constraint value are assigned. After that multi objective functions is derived for using of that, such as fuel cost, voltage deviation, voltage minimization, real and reactive, voltage stability. Those are the multiple objective functions. So those kind of functions can applied into the algorithms, and then which one is the best algorithm we can get, and corresponding output we will derived for that. So those are the main thing is implemented in this process. So those kind of parameters value we getting and solved that. Next we see about the running process of our product. In this proposed implementation is done in MATLAB environment. So in this process is done in the M file coding format. First to open the MATLAB main file, after that we get the new script file. In that script file we writing the coding. In that coding initially we calling the mat file from the IEEE standard bus system data. So in that data having parameters values, so those values is getting into the MATLAB M file. Then we create a command for solving the objective function within the equality and inequality constraints. then that corresponding objective functions are derived using of the formulation. Then we write a command to call the algorithm, ICA algorithm. So in that algorithm we calling that, then the corresponding output will be optimized and value will be get, then that value is getting, then that is given into the plotting process. In the plotting process we give the command which one is the y-axis, which one is the x-axis, and what is the title of the plot, and those are the given, and then click the run icon, the output, corresponding output will be shown. So these are the main process to find out that. So first one is the optimal allocation of 39 bus system. For number of buses is y-axis and generation bus allocations is x-axis. And next one is the voltage profile and bus number for 39 bus system. So those kind of values are given, and the y-axis voltage profile in per unit, and x-axis is a bus number. And also in next waveform is the stability index and bus number or 39 bus system. So x-axis is a bus number and y-axis is a stability index. So already we told the overall bus system is 39, so this kind of, so this is the impressive commutative algorithm, best cost and iteration value. And next one is the cuckoo search algorithm, best cost and iteration value. So finally we can find out the values which one is the best. So cuckoo search algorithm is best compared to the ICA. And also similar process is to 69 bus system, and those kind of variables we can get. Thank you for watching this video.